Hi there, this is my submission for Lab 4, Oscillations. First, I want to start with the introduction and the purpose of this lab. The purpose was to track the motion of a mass on a spring and then use the data that we got from Tracker to create GlowScript code. This will give us two models to compare between. We'll create plots of potential gravitational energy, kinetic energy, spring potential energy, and total energy change. Now, I want to continue the introduction with describing our system and surroundings. For our system, we're going to include the Earth, the spring, and the mass, and in the surroundings, we're going to have nothing. This is due to the fact that we want to use the potential energies that are dormant inside the system. Now, according to Newton's second law, we were able to use velocity update formula and the position update formula that we've used for pretty much every other lab. Now, and for our new topic, we're going to use the energy principle. Delta E is equal to work surroundings plus Q. This means that we can set up our change in energy equal to the kinetic energy plus the potential gravitational energy plus this potential spring gravitational energy, and we know this will be equal to zero due to the fact that our change in our system is going to be uh, zero because we don't have anything from the surroundings affecting us. All right, now I want to describe a diagram of what will happen in this lab. So when we have our mass attached to a spring, we know that the spring force will be pushing down when compressed, and gravity will always be pressing down. However, when our spring is stretched, we know that the spring force will be pointing up towards the attachment point, and the gravity will be pointing down. So now here are some models. Here's our tracker video. From the pre-lab, we know that the mass is 0.7 meters away from the appended point. This will help us calibrate our code later. And from this, we're able to set that our spring constant is 6.83 because this is the oscillation period for our object appended to the spring. Now, here's a sample of our code. As we can see, the red and green portions of the data cancel each other out in the graph, and it will always equal to zero. So setting up our initial conditions and putting them into GlowScript, we have our data from Tracker, and we have our ball, starting with our ball mass. Then we go into our position of the ball. The ball is our mass in this scenario. So here's the data that we got from Tracker, and we just went and put it into the vector, and then we imported the spring constant, and the relaxed length of the spring, it was measured to be 0.123. Now we just find everything else, and then finally we have our kinetic energy, our potential gravitational energy, and our potential spring energy, and then using the formulas that were in the introduction, we're able to calculate this in our code. Here we're going to be converting formulas into code. Here, our total length of the video was 9.402 seconds, so that was the duration of our loop. For our prediction formulas, we use the prediction formula for velocity update and position update. And then we used, to find the new energy, we used the energy from the original prediction that we did and then the new prediction. Now, here's comparing the graphs. After running the code, there are two plots that are produced. One is the x position versus time, and the other is the y position versus time. On top, we have the x position versus time. This shows that our code is pretty accurate to our tracker data, but starts to get less accurate because of our prediction formulas. This is because we're not accounting for friction or drag. Our bottom graph is in the y position. And with our code, it shows that there's a large overestimate of the y position, and there's an overestimate because of the amount of displacement of the spring. Wrapping things up, here's the what do you mean? What does it mean? For our model system, is the energy principle satisfied? Yes, this model does satisfy the energy principle due to the fact that the green and red lines always are opposite to each other and add up to zero. This means that the energy principle is satisfied. Now, using data from our tracker to make estimates of the oscillation periods for the x position and the y position, here's what we can say. When looking at the apex of the periods, there are slight discrepancies. X and y are slightly off, probably due to the fact of friction or drag. Now, when getting the oscillation periods, we find that the y coordinate or the y data and the x data are slightly off. Because of this difference in the time period for oscillation, it causes there to be a discrepancy in our observed versus predicted models. I used the data collected for the x to make the spring constant, and this caused my predicted data for the x position to match up better than the y position in our previous slide. Thank you very much, and have a great day.